Hello guys, in this video we are going to find the focal length of spherical surface when the light hits the spherical surface or passes from the air to the medium. Okay, it will rays will converge in one point, and this point is going to be focal point. So let's find out this focal point. The radius of curvature of this surface is known, it's equal to r, and now let's draw a ray that is parallel to our main optical axis. So for example, light hits this point of the surface and it will reflect after refracting. Okay, after refracting it will change its direction. For example, it will be somewhere here. For example, it will be somewhere here, and let's call this point S prime. S prime. Okay, the radius of this curvature, as I said, is known, so it means that we can find normal to the surface. Normal to the surface is going to be this one. This one is normal, and the angle of incidence is alpha. So this angle is equal to alpha. Okay, it means that this angle will be beta. This angle is beta. By the way, the index of refraction of the surface of the medium is equal to n. Index of refraction of outer space is equal to 1. It means that it's, for example, vacuum or maybe just air. Okay, so if this angle is alpha, it means that this angle is going to be also alpha. So let's write it down. This angle is alpha. So let's draw a straight line from the point of incident to the main optical axis. So it means this straight line, let's say its height is equal to just h. Okay, and let's draw one more angle. Okay, this angle is, for example, gamma. Let's say this angle is equal to gamma. Okay, and we need some points here. For example, this point is equal to A, this point is equal to C prime, this point is equal to just C, and I think that's all we need. That's all we need. So if our straight ray converged at point S prime, it means this is our focal length. So this distance from here to here is going to be our focal point. Let's say it's just F prime. It's F prime. Let's write down the Snell's law. Okay, 1 multiplied by sine alpha is equal to n multiplied by sine beta. Sine beta. And because this rays, all the rays is paraxial rays, it means that they are nearly parallel to our optical axis. The height h is going to be smaller, okay, much more smaller than radius of the curvature. So h is going to be much more smaller than radius of the curvature of this surface. Okay, radius of the curvature, it's this distance. It's this distance, okay. this distance equal to radius. So if h is much more smaller than radius, it means that our angles alpha and beta will be much more smaller than 1 because of that. So it means that we can use small angle approximation, and sine alpha is approximately going to be just alpha, as sine beta approximately is equal to just beta. Okay, from the Snell's law, it means that alpha, okay, 1 multiplied by alpha is equal to n multiplied by beta, or alpha divided by beta is going to be just n, index of refraction of our medium. Now let's look at some triangles. Let's look at the triangle A, O, and S prime. A, O, and S prime. It's this triangle. A, O, and S prime is this triangle. From this triangle, we see that this angle is going to be 118 minus alpha. But the sum of these angles is going to be 100 degrees. Okay, let's write it down. It means that our beta, angle beta, plus gamma plus 180 minus alpha is going to be 180. Okay, we can cancel 180. From that, we can say that our angle alpha is going to be just beta plus gamma, or it means our angle gamma is going to be alpha minus beta. What does it mean? Let's write down, instead of beta, from this equation we know that our angle beta is equal to alpha divided by n. So instead of beta, let's write alpha divided by n. So it means our angle gamma is going to be alpha minus alpha divided by n, or it will be just alpha multiplied by n minus 1 divided by n. Okay, let's write it here, that our angle alpha gamma is equal to alpha multiplied by n minus 1 divided by n. Okay, now we have our angle gamma. Sorry for that. Now we have our angle gamma, and now look at another triangle, the triangle C prime A O. C prime A O. That is this triangle, C prime A and O. This is the right angle triangle. Okay, this angle is right angle, and from that we have the ratio of H to the C1 and O is going to be our tangent alpha. So let's write it down. Tangent alpha is equal to, okay, tangent alpha is equal to H divided by C prime and O. Tangent alpha is going to be H divided by C prime and O. Or we can say that H is going to be C prime O multiplied by tangent alpha. As we said, these rays are paraxial rays. Because of that, we can say that C prime O approximately is going to be equal to radius, or CO. Okay, this distance C prime O is equal to this distance approximately, because C and C prime is very small. It's very small. Okay, C prime O is approximately, not equal, but approximately is equal to our radius, and tangent alpha is going to be just alpha because small angle approximation, because of small angle approximation is equal to alpha. So it means that I can write my equation in another way. H is equal to just R multiplied by alpha. H is equal to R multiplied by alpha. Okay, now let's look at also another triangles, another right angle triangle. It will be triangle A, okay, S prime and C prime. A, S prime, C prime. This is the right angle triangle, and this angle is equal to gamma, so it means that our tangent gamma is going to be H divided by this distance, C prime and S prime. Okay, now we are looking at another triangle, A, C prime and S prime, A, C prime, S prime. So from that triangle we have that tangent gamma is equal to H divided by C prime and S prime. Okay, now look at this triangle one more time. A, C prime, S prime. As we said, we are looking to paraxial rays, so it means that C prime and S prime is going to be equal to this distance F prime. So it means that it's our focal point. Okay, F prime. I can write C prime and S prime, C prime, S prime. Distance C prime, S prime is going to be equal to F prime. C prime and S prime is equal to my focal point, and tangent gamma is going to be approximately equal to gamma. Okay, it means that H is going to be equal F prime multiplied by gamma. But we know that our angle gamma is equal to alpha multiplied by n minus 1 divided by n. Let's write it down. F H prime, just H, is equal to F prime multiplied by gamma. Gamma is equal to alpha multiplied by n minus 1 divided by n. So we have another H, equation for H. So these two equations are equal. So let's call this equation is 1, this equation is equal. Second equation, so first equation is equal to second equation. So it means I can write here that R multiplied by alpha is equal to F prime multiplied by alpha multiplied by n minus 1 divided by n. I can cancel here my angle alpha, so F prime is going to be, I can write it like this, n divided by F prime is equal to n minus 1 divided by radius of the curvature. Or let's write it like that. N divided by F prime is equal to just n minus 1 multiplied by 1 divided by R. Okay, we found that how focal length depends from index of refraction and radius of the curvature of our surface. This is our final formula. Okay, thank you for your attention. We will continue in the next video.